The measure of an angle formed by two secants, okay, we had some vocabulary at the very beginning, but a secant runs outside the circle. Two tangents, a tangent touches at just one point, and if we drew, we already learned this one, if we drew from the center to that tangent, it would make a right angle. And maybe a secant and a tangent drawn from a point outside the circle is half the difference of the measures of the two intercepted arcs. It's wordy, I know, but here's a few key words. Outside the circle, half the difference. Okay, once you know the key words and you've done a few problems, it'll make more sense. So let's jump in. LO, the arc, is 88. That's the sound it makes. MN is 26 degrees. Find the measure of angle K. I want to point out that this is just K. You could call it NKM. You could call it LKO. You could call it OKL. You could call it all kinds of stuff. But if this is the only angle with a vertex there, then you can just use one letter. All right, now you know. So angle K, I'm going to call it X degrees. We don't know the measurement. X degrees is, well, it's outside, so it's half the difference. So 1/2 of the difference. So don't add them, subtract them, do big minus little. That way we don't run into negative angles here, because that's not going to happen in this lesson. So we're going to do, oops, I put X degrees. Technically it would just be X equals, unless I'm going to put degree symbols on that too. It'll be consistent. So X is equal to, let's just do this. 1/2 of 88, that'd be 44. 1/2 of 26 would be 13. And that's going to give me 31. So X is a 31 degree angle, so angle K is 31 degrees. All right, that wasn't so bad. So just to recap, we've dealt with inside, which is half the sum, and now we're dealing with outside, which is half the difference. Okay, really, that's all you need to know. So in circle O, that's what this means. You always name a circle based on its center. Measure of angle K is 22 degrees. And measure of angle O is 18 degrees. This is the only angle at O. This is 18. Find the measure of LQ. That's what the M stands for. And so LQ is what we're looking for. We'll call it X. All right, what are we dealing with here? Okay, let's go back to the very beginning of the lesson. Well, after the definitions, there was something that was said about how the measure of a central angle is the same as the angular measure of its intercepted arc. All right, again, wordy, but it's the same reason that this 16 degree central angle means this is a 16 degree arc, or this 90 degree central angle is the same as a 90 degree central arc, or it's 90 degree arc. So this 18 degree central angle means I have a 18 degree arc, okay? So now I have everything I need. I'm dealing with an angle outside the circle, and it is 22. And it is half of the difference of this arc and this arc. I don't need this one, I don't need this one. They're not part of this process, okay? It's gonna be that big one minus that little one. And I just wrote on my finger. I could finish it out and put like eyes in a mouth, and that's not. X minus 18. And I'm gonna solve this. So let's grab a green pen, double everything. That's gonna wipe out our fraction, lucky us. We're gonna have 44 equals X minus 18. And we're gonna add 18 to 44, and we're gonna get 62. Looks good to me. So LQ is 62 degrees. All right, let's move on. This one looks different, but it's the same idea. So let's just kind of look. This angle is 1/2 this arc minus this arc. It's just configured differently because this one's a tangent. So Q, angle Q, is 32 degrees. And arc, RS, whoa, RS is up here. I told you we weren't going to use it. I lied. 134. Find the measure of arc SP. I'm looking for this guy. Oh my goodness. Now, again, a minute ago, I went like this, and I'm like, it's going to be 1/2 this minus this. And okay, fine, let's go. 32 is 1/2 of something I really don't know that they didn't ask for, minus X. And I'm looking for X, but I have another gap. Okay, so here's what's going to happen. I don't know what this is, but here's what I do know. I know that this entire thing is a whole circle that makes 360 degrees, right? So this whole thing makes 360 degrees. So if I subtract away 134 and x from 360, I'll get this arc. Now I'm ignoring the angle, I'm just talking about the circle. So this little guy right here, let's use blue, no reason, just for fun. This arc is 360 minus 134 minus x, okay? So this is fine and it's ugly, but I mean it's fine and it's ugly. It's fine, but it needs to be simplified a little bit. So we're gonna do 360 minus 134. And when we do, we're gonna get 226. So this is really 226 minus x degrees. And so that's what's gonna go here. And in the end, we're gonna have an equation that just has x in it and it's gonna work out. So we're gonna have 226 minus x minus the other x. So again, 1/2. This is 1/2 of this minus that, and that's it. So I'm not even gonna show the doubling, I don't feel like it. So 64 equals, the 1/2 is now gone, 226 minus x, that's minus 2x. Okay, well, let's subtract 226 from both sides, and we're gonna get negative 2x, and that is equal to this guy right here, which would be negative something, 162. Yeah, it is. I'm gonna double check. Yeah, it is. All right, we're gonna divide by negative 2. About to find out what x is, and that's what they asked. They asked for this, and that is x. So when we divide, we're gonna get 81. 81, so this is an 81 degree